Hi all, today I want to talk to you about blood types. I'll be discussing the ABO blood typing system, which is the most common way to identify what blood type a person has. Okay, so what are blood types? Everyone has a blood type. There are some rare blood types, let me know if you want a video about that. And your blood type is determined by your red blood cells. Red blood cells are a component or a part of your blood, so let me know if you want a video on that as well. And red blood cells have antigens on them, which will determine your blood type. Your blood type can be A, B, AB, or O, and then it can be positive or negative. And sometimes your blood type can actually have impacts on interesting things, like some studies have suggested that type O blood makes you more attractive to mosquitoes. But some studies have also suggested that type O blood makes you less susceptible to contracting COVID-19. So what are antigens? Basically, antigens are markers. They can be made of protein, lipids or fats, sugars, carbohydrates, or even nucleic acids like DNA. The immune system reads these markers, and then it uses those antigens to determine whether something is self or non-self. So this is how the immune system knows not to attack the body. Of course, there are exceptions, like if someone has an autoimmune disorder. If you'd like to hear more about those exceptions, let me know and I'll make a video about it. Now, red blood cells have antigens on their surface, and these antigens are what determines a person's blood type. There are 3 antigens that determine a person's blood type. 2 of them are easy to understand, A and B, and the third is a bit more confusing and is called Rh. Rh is the one that determines whether someone's blood type is positive or negative. So to understand blood types and how our blood type is determined, we have to talk about genetics for a second. So in genetics, one common theme is that traits are passed from the parent to the child through the DNA. So for each gene, which is a segment of DNA that determines a trait, each person gets 1 copy per parent. Therefore, each person has 2 copies of each gene, 1 from each parent, barring exceptions. Let me know if you want a video about the exceptions. Some traits are dominant, which means that if you have even 1 copy of the gene that codes for that trait, you will have that trait. Other traits are recessive, which means you will only have that trait if both copies of your gene code for that trait. So one example of dominant versus recessive genes is whether you're able to roll your tongue. The dominant gene is that you are able to roll your tongue. The recessive gene is that you are not able to. So what happens is if you get 1 copy of the gene that allows you to roll your tongue, you will be able to do so. But if neither of your genes code for the ability to roll your tongue, you won't be able to. So the reason I wanted to explain that is whether our red blood cells have or do not have a given antigen on their surface is determined by the genes we receive from our parents. The gene that codes for the A antigen is dominant. The gene that codes for the B antigen is also dominant. So at this point you might be wondering, what happens if you get 1 A gene and 1 B gene, 1 from each parent? Well, a slightly more advanced topic in genetics is codominance. With codominance, 2 different dominant traits are inherited from parents, and both traits are exhibited rather than just 1. A and B genes are codominant in this way, so if you get 1 A gene from your mom and 1 B gene from your dad, you will have A antigens and B antigens on your red blood cells.